Larland and is located in a completely different direction, namely in the constellation of Ophiuchus, and 1.7 light-years further than Proxima. This little star is considerably smaller than the Sun, being only 0.17 of its mass and diameter. In fact, it was discovered comparatively recently, even though it's the fastest moving star in the sky, crossing the distance equal to the diameter of the full moon in 180 years. The flying Barnard is notable for its rapidity of movement. It moves towards the Sun, and eventually it is going to be closer to us than Proxima Centauri. The color of the star is the direct indicator of the temperature on its surface, just like a metal rod, which when heated first turns red, then orange, after that yellow, then white, and finally blue. For decades, Californian scientists have been making great efforts to discover planets in the vicinity of Barnard's star, but so far there are no data as to their existence. Here is another cluster of brown dwarfs, the Constellation of Vela, or Sails, located in the southern hemisphere. This constellation is our second closest star after the Sun. Interestingly, it is difficult to observe from the territory of Eurasia. You can see only part of it in the southern regions of Russia, and the more to the south you are, the higher the chances to observe the constellation. By the way, the best conditions for observing at least some parts of it are in February. Speaking about the stars of this constellation, the brightest one should be mentioned first, Gamma Velorum. It is also nicknamed the spectral gem of southern skies for its rays, which boast incredibly bright emission lines as opposed to dark absorption lines, which are generally more common. That is the reason for the rather exotic spectrum of the Gamma star. 800 light-years away from us, this star is the second largest in the constellation and is made up of at least 6 components. Also, Gamma 2 Velorum is also generally considered rather bright. It includes several stars, one of which belongs to the Wolf-Rayet set of stars. But these aren't all the massive bodies in the Vela constellation. For example, the mass of the Lumen 16 system is 30 Jupiter masses, with its brightness flaring up and fading from time to time. It is almost 7 light-years away from us. At the same time, the mass of another component of Lumen 16 equals 50 Jupiter masses. This binary stellar system was discovered comparatively recently, in 2013, while no celestial bodies or exoplanets have been discovered in its vicinity. We really love and appreciate our audience, that is you, dear viewers. That's why we try to provide exciting content worthy of your attention. It is thanks to you that we improve and carry on in our spaceship. Your views are the best motivation for us to create more videos about stunning facts about the infinite universe. So we'll be on cloud 9 when we see your like under this video and a comment with some fascinating and unconventional ideas you'd like to check out in our next video. See you later, dear friends. The world we live in seems to us rather clear-cut. It's hard for us to imagine flying mountains, enormous space anomalies, or objects thousands of times the size of the Sun. However, a lot of what would normally seem to be a figment of one's imagination actually exists in the universe. However, it is billions of kilometers away from us. A perfect example of these eerie celestial objects are black holes. Their sheer existence was considered impossible until only recently, when on the 10th of April 2019, the National Science Foundation in the USA showed the world an image revealing a black hole in the middle of the Messier 87 galaxy. This object has a mass approximately 6.6 billion times that of the Sun, with a diameter of about 100 billion kilometers. Just to compare, the diameter of the Earth is only 12,742 kilometers. This hole falls into the category of supermassive black holes. A similar object can also be found in the center of the Milky Way. It is called Sagittarius A and boasts from 2 to 5 million times the Sun's mass, according to different estimates. The diameter of Sagittarius A is 45 astronomical units. In other words, 45 times the distance from the Earth to the Sun. But is it possible to admit of the existence of even larger black holes in space? And which of them is the largest? Let's figure it out. A black hole is a term referring to an area in space with an incredibly powerful gravitation in the center. As a rule, these objects are rather small at first and are able to expand as they actively build up their masses. Black holes are categorized according to their masses. The heavier ones are called supermassive black holes. Those of them whose masses reach from 100,000 to 10 billion times the mass of the Sun fall into this category. At the moment, scientists haven't formed a unanimous opinion as to how these objects come about in space. According to the most popular theory, that of gradual expansion, when a black hole appears, it has a mass typical of a star, and later on it grows by sucking in the surrounding matter. The amount of information accumulated by science about these objects is rather scarce, but even based on the current data, a supposition can easily be made about there being at least several such holes in the center of any large galaxy. In the time the universe has existed, a few million or even billion of black holes are likely to have been formed in it by now. At least today, only a small fraction of them is known to us. The champion in terms of its mass is the black hole in the center of a quasar known as TON 618. This object was stumbled upon in 1957 when white dwarfs were being explored and initially caused a lot of puzzlement on the part of the scientists. The notion of quasars was to appear only 6 years later. That is why the nature of the object was rather vague. On photographic plates taken with a 0.7-meter Schmidt telescope, it was listed as number 618 and described as decidedly violet. It was only in 1970 that radio emission from TON 618 was discovered at the Institute for Radio Astronomy of Bologna. This emission was indicative of the fact that it was a quasar, and moreover, the most luminous quasar known to science at the time. It is assumed that there's an accretion disk of hot gas in TON 618 surrounding a gargantuan black hole in the center of the galaxy. The gas must move around the disk at a tremendous speed, reaching 7,000 kilometers per second. This object is located in the constellation of hunting dogs, or Canis Venatici, and is 10.37 billion light-years away from us. The galaxy containing TON 618 cannot be seen from the Earth due to the luminosity of the quasar itself, which is 140 trillion times as intense as that of the Sun. The contemporary view on quasars defines them as active nuclei of galaxies at the first stage of their formation. The nuclei's supermassive black hole sucks in the surrounding matter, thus forming an accretion disk. This disk is the source of luminosity of enormous power that is sometimes more intense than the aggregate luminosity of all stars and galaxies like ours. The brightest quasar, which was discovered in January 2019, has the luminosity of about 600 trillion suns and is 12.8 billion light-years away from the Earth. What could be the mass of an object finding itself in the center of a light cannon like this? According to today's estimates, the mass of the black hole in the center of the Ton 618 quasar reaches 66 billion times the Sun's mass, which makes it the heaviest black hole in our galaxy known to science. Black holes of this mass are categorized in a different group and are referred to as ultramassive black holes. In fact, the Ton 618 quasar isn't the only object in this category. Within the constellation of Cancer, for example, which is 3.5 billion light-years away from us, the OJ287 quasar is to be found. It has a black hole in the center and is 18 billion Sun's masses. In the center of the Phoenix cluster, there's a rapidly expanding black hole, which at this moment is 20 billion times the Sun's mass, building up 60 Sun's masses a year. One of the best-known black hole giants is located in the galaxy NGC 1277 within the Perseus constellation. The object reaches 21 billion Sun's masses, and its event horizon diameter equals 130 billion kilometers, which is 15 times the distance from Neptune to the Sun. However, at the moment, this giant practically isn't being active. Speaking about size, the undisputed holder of the first place on the list is admittedly another well-known space object, namely the black hole in the center of Holmberg 15A, a supermassive elliptical galaxy located in the constellation Cetus, or the Whale, 700 million light-years away from the Earth. This black hole isn't a champion in terms of its mass, which is 40 billion times the Sun's mass. Its dimensions, however, can't but amaze. According to today's estimates, the event horizon of this black hole could be as big as to accommodate the entire solar system. Its diameter is approximately 790 astronomical units. The Holmberg 15A galaxy must have been formed as a result of the collision of two smaller galaxies at some point in the distant past. A similar process is likely to be expected in our system as well, when the Milky Way collides with the Andromeda galaxy in 4 billion years' time. For now, astronomers plan to continue studying the phenomenon of the black hole in Holmberg 15A by carrying out complex and detailed modeling. Scientists are going to collate the results of theoretical calculations with practical observations in the future in order to try to establish how exactly it was possible for a tremendous black hole to come into being inside the two galaxies on their collision. In comparison to the objects mentioned above, our own planet may seem of no significance at all on the overall space map. But it should be noted that the age of practically all the supermassive objects in the universe is several times that of our Earth. For millions of years, these black holes have been gaining in their masses and expanding as the time went by. Today, we can observe their activeness as the result of the development of the entire universe. It is quite feasible that most of the ultramassive black holes were formed as a result of smaller holes merging. A similar process takes place when they collide, which is accompanied by the emission of gravitational waves. These occurrences must be the biggest contributors to the generating gravitational waves in the universe, and are exceptionally attractive to scholars of gravitational wave astronomy. By now, several similar signals which came about as a result of two small black holes merging have been registered by the American observatory LIGO. Perhaps we will find out the names of other champions in the list of space giants in the near future. And now, all we have left to do is just await new, amazing discoveries. We respect our audience. That is you, dear viewers. That's why we try to bring under scrutiny the most fascinating and bizarre things that can be found in space. So diverse and amazing. That's why grab this mouse of yours and hit the like button under the video. It's your likes and comments that encourage us to explore new boundaries. We will make it beyond these only thanks to your support and your subscription to the channel. See you around, dear friends. There are quite a few places around the world one hardly has a chance to access. For example, the bottom of the Mariana Trench or the crater of the Tambora volcano. But there are still more of these places to be found in the space. One of them is the vicinity of the remote planet Neptune. This celestial body is 4.5 billion kilometers away from us. To get there by an ordinary rocket would take us about 20 years. However, there was something from the Earth that was able to approach this planet and even take a few photos of it. Cosmo, the first in outer space. This was the famous Voyager 2 probe, which still remains the only apparatus to have flown by Neptune. Voyager 2 spent just a few months near the planet, but even in that short time span, it was able to get a great amount of valuable information. Neptune was the last big object to be seen by Voyager 2 before the probe entered the heliopore's boundaries and came into interstellar space. But what did the last shots from Neptune look like? Before you find out what it was, let's look at the probe's history. August the 20th, 1977. This is the day when Voyager 2 left the surface of the Earth. 41 years later, it was to go beyond the boundaries of the entire solar system. Initially, its mission implied only the exploration of Jupiter, Saturn, and their satellites. But the flight's trajectory presented the opportunity of flying by Uranus and Neptune as well. As soon as on July the 9th, 1979, Voyager 2 was 71,000 kilometers away from Jupiter. The probe also flew by its satellites Europa and Ganymede. The images received from the spacecraft gave grounds for putting forward the hypothesis of there being a liquid ocean under the crust of Europa. The observation of Ganymede showed that it was covered by a dirty ice crust. By the time 2 more years had elapsed, Voyager 2 was 101,000 kilometers away from Saturn. The probe flew by its satellites Tethys and Enceladus and transmitted detailed pictures of their surface. According to initial forecasts, that was supposed to be the end of its mission, but Voyager 2 continued on its course. January the 24th, 1986, the spacecraft approached Uranus and passed it at the distance of 81,000 kilometers. Voyager 2 sent a number of photos to the Earth. The planet's satellites, as well as its rings and surface, were to be seen in the pictures. It is thanks to them that 2 more Uranus's rings were discovered and the 9 already known ones were studied closer. 2 more years later, Voyager 2 found itself in the vicinity of the furthermost object of its mission and passed Neptune within 48,000 kilometers on August the 24th, 1989. It was able to take unique photographs of this giant and shoot Triton, its largest satellite. Active geysers were discovered on Triton, which came as a big surprise given the remote position and low temperature of this celestial body. Only 21 years after that did the probe cross the termination shock and entered the heliopause. 11 years on, and Voyager 2 passed through this area as well to come into interstellar space to stay. But what did the last planet seen by Voyager 2 look like? Many of you will certainly agree that Neptune rates as practically the most mysterious planet in the solar system. It is a body closest to Uranus in terms of its composition. It is perceived as a huge blue planet as a rule, and is even classified as an icy giant. Neptune's atmosphere is similar to that of Jupiter, and is mainly composed of hydrogen and helium. The planetary interior is for the most part made up of stone and ice. The color blue comes from methane in the outer layers of the atmosphere. Neptune's diameter earns it the 4th place among the other planets of the solar system, and it holds the third place in terms of its mass. This planet is 17 times the size of the Earth. Neptune is also known for its dire climate. The strongest winds in the solar system blow in its atmosphere, and according to some estimates, their speed may reach 600 meters per second. A wind of this force would upend any object of average size landed on the planet's surface. The temperature on the surface of Neptune is close to minus 220 degrees Celsius. But if you were to find yourself there, the cold and fierce wind would not be the most trying ordeal. What is much scarier is that 1 year on Neptune would cost you 165 Earth years. Since the time Neptune was discovered in 1846, just over a year has passed on this planet. So, what could Voyager 2 see around that cheerless place? The first pictures taken by Voyager 2 as it was approaching Neptune were received on the 23rd of January 1989, when the probe was 310 million kilometers away from the planet. As the probe got closer, the images revealed formations in Neptune's atmosphere. These 3 images were received at a 90-minute interval. The photos allowed scientists to see atmospheric clouds, as well as notice a huge dark spot. The size of the spot was similar to the Great Red Spot on Jupiter. It should be noted that this area on Neptune was 10% darker than the atmosphere surrounding it. When Voyager 2 got closer still, it was able to see the planet in color. These photos were taken from the distance of 176 million kilometers. There was a 5-hour difference between them, during which time the planet had rotated 100 degrees. The probe's next objective was the closest satellites. On July 3rd, 1989, it was able to take a picture of Triton and capture both Triton and Neptune in one image. The probe kept getting closer and launched another active series of picture-taking 35 million kilometers away from Neptune to capture the nebulae for closer study. Apart from the great dark spot, a few dozens of similar formations were observed. In this contrasting image, Voyager 2 managed to capture thin and bright clouds. This picture made it clear that they floated much higher than the great dark spot. The next couple of photos was taken at a 17-hour interval, and it could be seen that the great dark spot completed the almost full turn around the planet. The scientists realized that spots like these are able to move around Neptune at the speed of 100 meters per second. The Voyager's images also made it possible to gauge the wind force, which in some areas reached as much as 700 meters per second, which is practically the sound speed. The closest distance of the probe's approach to the cloud layer of the planet made it 4,900 kilometers. The images depict cirrus clouds casting their shadows on the layer of continuous clouds underneath. During its flight, Voyager 2 was able to take pictures of several satellites, for example Triton and Nereid. Having done that, the probe continued on its course and bid its last farewell to the views of this planet. The last image taken by Voyager 2 near Neptune does indeed look like a goodbye. The probe had entered a shadow at the time. That is why just part of the icy giant can be seen. That was the end of their short acquaintance, and Voyager 2 left those parts, never to return again. Voyager 2 still remains the only spacecraft to have reached Uranus and Neptune. Its successful mission was outstripped only by that of the New Horizons probe, which reached Pluto in July 2015. Voyager 2, however, will always remain a legend of space exploration. In about 300 years, it will reach the Oort cloud and will sail beyond it only in 30,000 years. It is highly likely that by that time more than one exploration mission to Neptune will have been launched, but the achievements of Voyager 2 can truly be called a worthy beginning of this story. What do the planets closest to us look like? Are there extraterrestrial life forms? These two questions have been preying on the brightest minds of the world for a long time. For centuries, people have come up with suppositions and theories, until in the 20th century, the scientific and technological progress enabled scientists to put into practice one of the most tremendous projects in space exploration. On the 5th of September 1977, the Voyager 1 probe was launched. 16 days previously, on the 20th of August 1977, its twin, Voyager 2, was launched. That was the beginning of a groundbreaking journey into the unexplored depths of the universe that has been going on for the past 42 years. During this long time span, the Voyagers have taken detailed photographs of Jupiter and Saturn, as well as their satellites. Uranus was closely studied, and its 11 moons were discovered thanks to the Voyager mission. It's the pictures taken by Voyager 2 that allowed scientists to be able to see one of the most controversial bodies in the solar system, Miranda, Uranus's satellite. The subject of big space travel was first broached in 1966. Gary Flandreau, still a student, published a scientific paper where he predicted the orbits of Jupiter, Saturn, Uranus and Neptune getting closer together by the late 1970s. The predictions proved to be accurate. On the 10th of March 1982, a full planetary parade took place. The 8 planets of the Solar System and Pluto were on the same side of the Sun at the angle of 95 degrees. The rendezvous of the giant planets provided opportunities for using gravitational maneuvering to fly the two apparatuses on the trajectories Jupiter, Saturn, Pluto and Jupiter, Uranus, Neptune. 10,000 possible trajectories were considered when the program was being worked out before the two of them were finally agreed upon. Apart from exploring furthermost objects of the solar system, the Voyagers have taken a great number of photos of our own planet, including one of the most well-known ones from a record distance of almost 6 billion kilometers. The idea of the picture, as well as its name, the pale blue dot, belongs to a prominent astrophysicist of the 20th century and an outstanding popularizer of science, Carl Sagan. The scientists didn't rule out the possibility of the Voyagers encountering extraterrestrial beings. That is why both spacecraft carried a gold-plated audio-visual disc with greetings in 55 different languages, significant scientific data, views of the Earth and its position in relation to its 14 pulses. Music holds a special place in the message to intelligent aliens. The collection of music includes classical works by Bach, Mozart, Beethoven, jazz pieces by Louis Armstrong and Chuck Berry, as well as folk music from around the world. The record also contains an instruction on how to access the data on its back. However, let us not dwell on the past, but look at the future of the Voyager project. Where are the spacecraft now, and what awaits these solitary space wanderers? The Voyager's chief mission, exploration of furthermost planets in the solar system, was completed long ago. Now, the main objective of both probes is studying transitive areas between the Sun and interstellar plasma. The Voyagers travel at 17.07 km per second and 15.64 km per second, respectively. At the moment this video is posted, the distance between the Earth and Voyager 1 is approximately 21.7 billion kilometers, while Voyager 2 is 17.9 billion kilometers away from us. The spacecraft's missions differ by their trajectory. Voyager 1 flew only by Jupiter and Saturn, while Voyager 2 went further and flew by Uranus and Neptune as well. That is the reason why Voyager 2 is never going to catch up with its twin brother. In 2012, Voyager 1 left the heliosphere boundaries to cross into interstellar space. It follows a hyperbolic trajectory, so Voyager 1 is not going to return to the solar system due to the gravitational force of the latter. Its twin overcame the heliopause only in November 2018. Leaving the heliosphere does not actually mean leaving the solar system. To do this, one has to go as far as the Oort cloud, a hypothetical region of the solar system and a place of birth of ice comets. Only there will the gravity force of our star become negligibly feeble. The Voyagers are powered by plutonium-238 radioisotope thermoelectric generators. After 42 years, the power of the probes went down to 55% and is now 249 watt as opposed to 470 watt at the time of launch. This does not allow full application of the probe's scientific equipment. Only 5 out of 10 devices are operating now. The cosmic ray system, the low-energy charged particle instrument, the magnetometer, the plasma wave subsystem and the plasma instrument. Now the Voyager mission members are struggling to maintain the equipment's operation. According to preliminary estimates, the minimal energy generation required for scientific studies will be sustained till 2025. This time is hoped to be sufficient to explore interstellar space, in particular the structure of the heliopause. In the future, the data may be used in planning missions to the stellar system closest to us, Alpha Centauri. By about 2030, the probes will switch into a radio beacon mode and will transmit the last signal to the Earth in 2036. Thus, the life expectancy of the Voyagers will reach about 59 years. One must admit it is quite a period for a space trip. In about 300 years, Voyager 2 is going to reach the inner edge of the Oort cloud and will completely leave it only in 30,000 years. According to the data provided by the Hubble telescope, it will take Voyager 2 approximately 2,000 years to cross the gas cloud in which the solar system floats. It will take the probe about 90,000 years to get into other interstellar clouds. The remains of the Voyagers are presumed to reach stars as well. In about 40,000 years, Voyager 1 is supposed to pass Gliese 445, a star in Camellia Pardalis, within a 1.6 light-years distance. Meanwhile, its twin will approach Ross 248, a star in Andromeda, at 1.7 light-years distance. In 296,000 years, Voyager 2 will fly by Sirius at a 4.3 light-years distance. Life-sustaining planets are unlikely to exist in the vicinity of either Ross 248 or Gliese 445. Both of them are red dwarfs, each of them hardly half the mass of the Sun. Ross 248 is notable for being a flare star, that is, one that spontaneously flares up. At about the time Voyager 2 approaches Ross 248 closest, the closest star to the Sun will for a short time be Ross 248, and not Proxima Centauri. The Voyagers are to remain eternal wanderers in the universe. They won't be able to leave the Milky Way and are destined to wander around our galaxy. They have lived through scores of failures on their journey, but in spite of that, they continue to operate, transmitting important scientific data to the Earth. With the initially planned 5-year lifespan, they're pushing their 4th decade of service. As far as I'm concerned, the Voyager project is the most successful idea in the history of space exploration. The data received during the mission have changed man's perception of the solar system. It is hard to tell whether an extraterrestrial race will ever read the message on the golden-plated discs on the Voyagers. Since the solar system is 15 times faster than the Voyagers at circling around the galaxy center, it is possible that our planet will recapture the remains of the probes in some hundreds of millions of years, maybe the message aimed at aliens will eventually be a greeting from a distant past to the human race of the future. Please leave your comments about what other impressive space exploration programs you would like to find out more about. Like the video if you enjoyed it, and don't forget to subscribe. Keep in touch. Have you ever peered into the night sky in the hope of spotting a shooting star in this infinite darkness, or else a UFO or another sign that would indicate that we're not alone in the universe? Throughout history, man has been keen on the idea of noticing a sign of any kind that would show that we're not the only ones in the space. It could be discovering light after a stretch of darkness, stumbling upon life forms at the deepest point of the planet, or finding an ally in the farthermost corner of the universe. But is it possible, or does absolute nothingness pervade all around us? The first in the space. For most people, the universe is infinite space, which the human brain is incapable of imagining. Thanks to the basic knowledge received at school, most of us see the space as a more or less clear structure of galaxies, planets, and constellations. But is this notion quite accurate? The universe conceals a staggering number of mysteries, and it might take centuries to get to the bottom of even one of them. Imagine how much time it would take an ant to nail the principles of market-based economy, or the amount of time sufficient for a fish to understand the structure of a plane. Scientists encountered the first riddle of this kind back in 1978, when they discovered a phenomenon that did not fit into the accepted notions about the universe at the time. About 700 million light-years away from the Earth, a mysterious phenomenon was discovered by American scientists in the direction of the Voyager constellation. It was dubbed supervoid. Let's see the chronology. 1961. The astronomers' community's attention is drawn to pre-large structural elements like accumulations of the second order. 1978. The first two theses are published on the subject of voids in a large-scale structure, where voids are mentioned discovered in front of the Northern Hemisphere constellation of Berenice's Hare. 1981. The first large void is discovered in the Voyager constellation. Right, hold on a moment. And now in detail. Isn't the universe comprised of a structure of planets and galaxies equally distributed around the space? What are these voids then, and where do they come from? I bet it's a similar question the scientists were asking themselves in 1981. At that time, the universe was perceived as a sort of canvas, filled completely with constellations and galaxies. The image of unfathomable sky was as straightforward as a Euclid's axiom. Stars are grouped in galaxies, and galaxies coalesce, thus forming gravitationally interdependent accumulations. Neighboring galaxies are comparatively close to each other by the space standards, and the voids between them are insignificant, thus rendering them not worthy of astrophysicists' close attention. A wrong one here. Has the universe ever been simple, what with its great attractors, black holes, wormholes, and other mysterious occurrences? In 1981, astronomer Robert Kirshner and his team discovered a shocking phenomenon that was dubbed the Voyager void, or the Great Nothing. The phenomenon was an enormous spherical region with a rather small number of galaxies. Most of the space was filled with absolutely nothing. A great nothing, which was impossible in the accepted perception of the universe. It made one assume that for some reason the formation of galaxies was prevented by something in this region, or else this something covered them from the scientists' view. With a similar universe density, not less than 10,000 galaxies would be expected there. Only 8, however, were discovered by the scientists. The odd region was about 700 million light-years away from the Earth, with the void 330 million light-years in diameter, which is 0.27% of the diameter of the observable universe. The Voyager's void instantly attracted the attention of scientists from all over the world, and the search for galaxies within the void became a sort of competition among astronomers. In 1988, 3 more galaxies were discovered by scientists. Then there were 15 in 1989. 1993 heralded the number of 27 known galaxies. In 1997, the score stopped at 60 galaxies. But this still did not look enough. During the 40 years of its existence, the mysterious void has kept attracting astrophysicists. The first riddle that puzzled the scientists lay in the fact that galaxies never went into the void, but bounced off. Does it ring a bell? Maybe some sort of a white hole is concealed there in the infinite darkness. Scientists are still uncertain as to the origin of the Voyager's void. In computer models, little voids are formed when galaxies merge and leave their place. But it doesn't account for the Voyager's void. Galaxies would not have enough time to vacate space for the voids to form. Taking into account the age of the universe and the speed with which it expands, the size of the void would grow tens of millions of light-years, but not hundreds. The Voyager's void is too great to fit these calculations. That is why a new theory was conceived. According to some scientists, large voids are formed by smaller ones, just like a big soap bubble is formed by smaller bubbles. The way the galaxies are arranged in the Voyager's void could be indicative of just this. They're in a row, and this could be the remains of 2 voids that once coalesced. There are other numerous theories as well. Perhaps you also have a hypothesis as to what could be concealed in the void. Please leave your comment. Even though studying this phenomenon is a complicated task, the Voyager's void is just the first stage of studying voids in the space. Scientists have by now lost count as to how many voids there really are in the space today. Voids account for a large portion of the universe, and their main feature is their mystery. It is not even clear how they came about. They are conventionally believed to form when parts of matter blend and vacate space. In theory, voids were small in the early universe, and later on they expanded. But so far, no general rules of void distribution have been formulated. Scientists estimate them to occupy half of the universe, or even most of it, up to 90%. Mikhail Anisimov wrote, "The void is a desert, an ideal vacuum where particles of matter travel through millions of light-years without collision or change. The void is a repository of motionless time for them. There, the time stands still. Indeed, just imagine, hundreds of light-years of absolute nothingness, darkness and cold, where time is virtually non-existent. From the technical point of view, this void is not supposed to exist, as contemporary theories admit of only much smaller unfilled spaces. The dimensions of this void monster